Hi, this is Kelly Hill, technology reporter for RCR Wireless News. I'm here today with Mike Thielander, who is president of Signals Research Group, and also Kurt Bantley, who is senior solutions architect for Spirent. And we are going to be talking about some of the recent testing that they've been doing in terms of VoLTE specifically. And gentlemen, I'm wondering if you can maybe just start us off with a sense of what you were hoping to accomplish with this testing that you did. How you went about it, give us a sense of the methodology, and then maybe we can start to talk about some of the results.
Sounds good.
Okay.
So I guess I'll kick things off, then I'll turn it to Kurt for a little bit more detail there. So Spirent and I have been working together, Signals Research Group have been working together for probably the last 7, 8 years, I guess, doing a lot of testing, and our most recent campaign was doing an analysis of VoLTE. So we picked the Minneapolis-St. Paul market to kind of go out there and do an assessment of VoLTE and how it performs, both relative to circuit switch, voice, as well as to over-the-top applications, in this case Skype. And we really wanted to look at it from several different angles. One is just the basic call quality. So how does the call quality compare to 3G voice versus Skype under numerous conditions? Looking at the impact on battery life. So if you're placing a lot of voice calls, how does your battery life compare with the various voice applications? Looking at it from the perspective of the impact on network resources. So if you're supporting a voice call over VoLTE, say, versus Skype, how much of the LTE network is actually going to support your call? And then finally, we looked at the basics of call setup and call reliability. So people talk about, for example, the circuit switch fallback time and the amount of time you have to wait for that call to be set up. Well, how does that compare to VoLTE? And then can VoLTE actually reliably set up and maintain a call? So that's kind of the basic background. I'll turn it over to Kurt to talk about a little bit more details as far as the test methodology.
Sure, thanks, Mike. So in the test methodology, we used a couple of different tools that Spirent has specifically tailored for field testing. So the first thing we used is we used our Nomad tool to take a look at voice quality using the Polka algorithm. And we made sure that we really wanted to benchmark HD voice. So we were using the super wideband reference file, and everything was benchmarked against that file, including our circuit switched voice numbers. Second thing is we wanted to take a look at battery and current consumption, so we used Quantum to look at what was being used during both the VoLTE call and additional applications running. And third, we actually had our datum tool running in the background on both the VoLTE and over-the-top services so that we could simulate the user doing things like browsing the web, checking email, maybe watching a video while they're carrying on a conversation. So we watched how those ancillary services that were going over our default bearer impacted not only the over-the-top experience, which is also on the default bearer, but our HD voice VoLTE call that was on a dedicated bearer.
Okay, great. And so talk a little bit about what you found. Mike, maybe you can start us off?
Sure. So I think everything was pretty much as we expected. There were a few surprises, definitely. I mean, clearly with HD voice and VoLTE, there was a big difference relative to 3G circuit switch voice. And it's fair to point out that in the case of AT&T, they're not using HD voice for 3G. So you'd expect there to be a big difference. We didn't look at, some operators, T-Mobile, for example, have HD voice on their 3G network as well. We obviously didn't look at that in the case of AT&T. But clearly from a voice call quality perspective, there was a big difference. Comparing it to Skype, under, I would say, lightly loaded conditions, there was a difference. It wasn't huge, but there was a difference in the scores. What really started to become interesting is when you started having lots of other traffic on the network. So Kurt talked a little bit about having other applications running in the background. That in some cases had a huge impact. I'll give you an example. So when we were running datum in the background on the phone, it would literally cause Skype to crash. You couldn't even maintain the call. There was no voice activity detected. You compare that to VoLTE, and essentially the MOS score was unchanged. So no matter what was happening in the network, happening on the phones, because you had a dedicated bearer, the call quality was unimpacted. The other, I think probably the most interesting thing is that we did some other testing. So one of our methodologies was we used other devices in our test vehicle to help generate traffic. So we were testing by the Minneapolis-St. Paul airport. There's lots of data traffic there, but we tried to do all we could to generate more data traffic. And one of the things I was doing on my own personal smartphone, which was separate from the two test phones that had VoLTE, is I was downloading Angry Birds. And I was going to the Google Play Store, and clicking on downloading Angry Birds, and we discovered every time that I did that, exactly when I started the download, the Skype call on two separate phones would crash. As soon as I stopped the download, the call picked up again, which is really strange because a simple download should not cause that to happen. It's not that much data traffic, but for whatever reason, the Skype call crashed compared to VoLTE. That wasn't the case. So that's really, I think, evidence that one of the biggest advantages of VoLTE is that you have this QCI1 dedicated bearer. So regardless of what else is happening in the network in terms of network utilization, other applications running, that VoLTE call is getting a dedicated bearer and basically a guaranteed QoS.
I think one of the things I'll add to that too is that I guess Angry Birds really is the killer application. But as we see now, people are really talking. They're trying to highlight the fact of simultaneous voice and data with VoLTE, and so that really then starts to weigh in on the dedicated bearer aspect of it, because we're setting the expectation that the user is going to be carrying on a phone conversation while generating this external data traffic.
Mm-hmm. Well, and I think that makes VoLTE interesting, as far as carriers go in terms of their competition against OTT. If we move into VoLTE and, suddenly you can rely on your carrier service because of the dedicated bearer, and if you start using OTT, you might be looking at more crashes and more interruptions. That could make some very interesting user choices on when it comes to OTT versus carrier services.
Right, because the other thing we saw too, Skype is, we kind of, in a way, pick on Skype, but the reality is Skype is probably the best or one of the best over-the-top applications as far as how is it designed. But there's a limitation to how far you can push that when you don't have the QCI1 dedicated bearer. So Skype could do some adjustments in terms of if there was some loading, we could see it actually adjust and almost like, if you will, self-correct. But once you really started seeing a lot more loading, it was eventually brought to its knees. And then separate from the call quality, there was definitely an impact on the battery life. So from a user's perspective, with VoLTE you get the better voice quality. That's subjective in a way. Some people may like, regular 3G voice, but even separate from the call quality, the battery life is a big thing for the user experience. And definitely, the battery life was meaningfully longer, high or mid double digits in terms of percentage relative to Skype. It did fall a little bit short relative to 3G circuit switch voice. So today on the test phone that we had in the AT&T network, it was maybe 15-20% longer battery life with good old 3G. That will change over time. I mean, as the operator starts to turn on more VoLTE features in their network, that will improve battery life, that will help. I think another implication or another factor could be the VoLTE client itself. So in this case, the VoLTE client was on the application processor versus actually being native on the baseband modem. And it's my understanding that once you start putting the VoLTE client on the baseband modem, you start turning on these other features in the operator's network, which they have yet to turn on. You will see that switch, and actually VoLTE will have a longer battery life than 3G circuit switch voice.
Now, it strikes me that there's one other question that I wanted to ask here. When you start talking about, doing downloads like Angry Birds, were you guys looking specifically at on the impacts of data downlink or data uplink, or did you look at both?
So we actually took a look at both. Primarily, we noticed that the downlink was a little bit more impacting to the voice quality for us, but we were actually bidirectionally loading the traffic.
Okay.
And we also believe that there's inherent TCP ACK-NAC that goes along with downloading something like Angry Birds and downloading an app. So it's not a UDP stream, it's TCP. So we know that we're definitely making the uplink have chatter as well during that. But we were trying to impact both the up and down links.
Okay. Okay. And I think, Mike, you also mentioned looking at network resources was another thing that you guys examined with this. Can you talk a little bit about that aspect?
Yeah, so I mean, definitely that was, from an operator's perspective, the consumer doesn't care, at least today, but from an operator's perspective, they definitely care about how much capacity is for a single voice call, be it Skype or be it VoLTE or some other over-the-top application. And again, there were some meaningful differences between the two. There's a lot of features that are included in LTE with the QCI1 bearer that allows it to basically be an optimized service. And to some extent, an over-the-top application can take advantage of some of those features, but it really falls short. So from an operator's perspective, when they think about, okay, how much scheduling, how much signaling is involved in sending the voice packets, how many resources are required to send the voice packets. Again, it definitely favored the VoLTE session, much more optimized in terms of the amount of resources that it required.
So what would you say that this illustrates for the industry? I mean, as we start talking about the amount of testing that has gone into VoLTE, it's been a long time coming, and we're still kind of getting there in terms of deployment. Are there any conclusions that you draw in terms of how close are we to seeing this take prime time? What are some of the key issues that operators are still need to be aware of and need to address before this can be something that is launched on a large scale?
Can I take that?
Yeah, you look like you're begging.
Go ahead, Kurt, and then I'll jump in.
Okay. So actually, I have to say from the commercial implementation, actually doing this testing on a live commercial network, I was thoroughly impressed with the VoLTE service. But I think what it points out is we're actually using two like devices from a manufacturer. I think what we're going to start to look at and what we start to need to think about focusing on is a lot of the device-to-device interoperability. So when I start taking devices from manufacturer A and testing it with manufacturer B, I think there's going to be a lot of these challenges that we haven't seen yet or that we haven't really focused at. So we've been kind of focused on core IMS functionality, basic SIP signaling, and things like that, but I think there's going to be a lot of device-to-device artifacts that we start seeing show up.
And I think I would add to that, probably the biggest challenge for VoLTE is not so much VoLTE itself, it's really the network. In Minneapolis, AT&T has good coverage, but it's not great coverage. And so we had a fair amount of instances where the VoLTE call would hand back to 3G, and it would do a smooth handoff using enhanced SRVCC. But we also had a few cases, where it would drop the call. That happened for Skype as well, and so it was not a VoLTE problem per se. It was really an LTE network coverage issue, and so AT&T is somewhat blessed in the fact that they have an underlying 3G network. They can do an SRVCC handover to the fallback. That's going to be challenging for somebody like Verizon, and I'm not quite sure how well that's going to work for them because they don't necessarily have as much continuity going back to their 3G network. The other thing I would add is that AT&T is also deployed at 700 megahertz, which is ideal from a propagation perspective. When I start thinking about an operator like a T-Mobile or a Sprint who's deploying LTE in the higher frequency band, and their coverage again is going to be challenging, I'm a little bit fearful how well their VoLTE service is going to work. Not so much because of VoLTE again, it's really the underlying LTE network. And I think operators really need to think about coverage and think about basically radio optimization of their network.
Okay. One other question that I wanted to ask, Kurt, you mentioned that you guys were using two like devices. I'm assuming the client was also the same, so this wasn't looking at interoperability between clients. This was two devices, same client. How did they do with calls?
Correct.
Is that correct? Okay.
Yeah. So I mean, both devices were the Samsung Galaxy S4 Minis, and so both using the same client, both using the same device, same chipset, same everything. So identically matched devices.
Okay. Great. Good to know. So you guys have been working together for a while on doing different interesting testing on the networks that are out there. What's next on your radar?
So one of the things to follow on with this is we thought it would be interesting to be able to take devices and start kind of benchmarking them against each other. So to do that, we want to take some of the network elements out of that so that we can have a controlled environment. So we're going to look at doing our next scenario as a lab-based test. We actually want to take several devices from several different manufacturers and several different client implementations and kind of benchmark those two devices against each other. So to see, performance variations amongst the different implementations. Once we kind of set a baseline of that in a controlled network environment, then we'll be able to migrate that and kind of reproduce that in the field and see if those differences that we notice in the lab can carry through into field test scenarios.
Mike, anything you want to add about questions you'd like to see answered?
Yeah, I think the other thing is I had alluded to, AT&T has not done, HD voice on their 3G network. On the VoLTE side, they're also using a lower codec rate than a T-Mobile. So I'm curious to go out into like a T-Mobile network where they've got 3G HD voice. They're using the higher codec rate on VoLTE to see how that performs, both from a MOS perspective, basically the call quality, but also how much network resources are required to support the VoLTE call. The other thing is video. So I think Verizon is launching or has launched their video service. It's a best effort video service, ironically enough. One of the operators up in Canada is using a dedicated bearer when they launch. So then again, how does Skype voice or Skype video is actually pretty impressive. How does Skype video compare against a IR94 or basically the standardized LTE way of doing video telephony? And that'll be interesting as well because Skype video has been around for a long time. It's highly optimized. I'm really curious to see how well Skype video compares to an IR94 application.
Okay, great. Well, we will look forward to you guys exploring those things and hopefully telling us more about it. So I've been talking with Kurt Bentley, who is Senior Solutions Architect with Spirent, and Mike Thielander, President of Signals Research Group. Gentlemen, thank you so much for your time.
Thank you.
Thanks, we appreciate it.